this just from something I noticed on the quiz. You have that guy's inequality, and they want you to solve it and express the answer in interval notation. Can anyone give me a start? What would you do?
X cannot equal -4.
Okay, quickly, you said, wait, Professor, I need to come up with those critical numbers, because I think, and many times I'll say do this, I think eventually we're going to use this. That's sign analysis process. Now he says quickly, Professor, X, I'm gonna call this step 1, X cannot be -4. I agree. What else might you pick up and consider as a critical number? By the time I get to my number line and place those critical numbers, then I'll start testing. Can someone tell me something else you may be looking at here, but be careful? Are there some other numbers I should consider as critical numbers besides -4? I can't use -4, but I'm going to use it as a critical number. What else? And that -4 came from the denominator. Suppose you look at the numerator.
Can't be -100.
Well, I'll look at this. The numerator, if I do this, guys, says x cubed. And by the way, I think that will factor by a difference of squares, which would help. Now suppose you consider it, just to get critical numbers. Also, he's already told me x can be a -4. I'll take that. Then you split this up. This set equal to 0. This set equal to 0. This set equal to 0. Guys, I think right quickly, that implies x 0, x is equal to what? 1, x is equal to -1. That came from my numerator, after I factored. Denominator, he says x cannot be a -4. Now, can I be wise enough to take all that from the numerator to denominator, this count problem, and place it on a number line and show sign analysis? If I can solve this thing. Now tell me, let's place all my critical numbers. Already he said -4 can be placed there, Professor, but you gotta make sure you place and show it's open. You can't use it, but it's there. Guys, now can I use the other 3? I have 3 more numbers to be considered as critical numbers. Can I, when I place these on the number line, which I will shortly here, can I darken them in, or should they also be open and showing that they cannot be included also?
Darken them in.
Why?
Because the equal sign.
That equal saves me. That allows me to use those on the top there. So guys, I got 0 out here. Beautiful. Let me darken it in. 1, darken it in. -1, we'll squeeze it in right here. Darken it in. Taken from a count textbook. So I got all my critical numbers. I looked at the top, I looked at the bottom, have all my critical numbers there. Thank you. You guys agree with all the critical numbers? From the numerator, denominator, be careful which one should be open. By the way, is it John? Yeah. If this equals mark had been missing, then what would I indicate over here? All of them would be open. And definitely this one, the -4 has to be open no matter what, because I can't use it. That would force a 0 denominator. Okay, so -4, and if that equals mark had been missing, the other 3 would also be open. The equals mark saved me for the top part. Now the testing. This is, here we go. You got a test here, here, there, look at this mess. Here, here. And you gotta choose a number of your choice, test it, just like you did on that quiz last night on one of those problems, and see what's gonna happen here. It's a little lengthy, and I'm gonna try out here -5 maybe, guys. Don't mess up, I'm on top of the board here. Between -1 and -4, guys, let's try maybe a -2. I'll squeeze that in. Between 0 and -1, I'm gonna try a -1/2. Squeeze that in. Between 0 and 1, let's try 1/2. And out to the right of 1, and we'll try 2. I think I've got all that going on for me. Let's see if I do. Okay, -5, keep in mind, we're not gonna crunch out a number. We're gonna just look back, and you'll say, Professor, where should I look? I'm gonna look back here on this one. Now, if you wanna think of it like this, which might be easier, the original looked like that. And I'm not putting it in factor form. -5, replace right here by -5, you're gonna cube it, that gives you a negative. -5 subtract 1 is -6, negative. -5 plus 1, negative. All over x plus 4, -5 plus 4 is negative. Now guys, what is that all together? I think on top is a negative. A negative times a negative times a negative. Is that a negative?
Yeah.
Over a negative. Turns all the way into what? A positive. Please tell me, is this a symbol that tells me I am looking for a positive? If it says greater than 0, does that imply I'm looking for a positive? That says you have discovered that this works. This is part of the answer. You see how it's working? Now, you see this time it's going to take me here. So I may not test the other intervals, all of them. I'm going to test one more. You're supposed to test all of them. I'm going to save myself a little time. Let me jump down to between 0 and 1, see if that works. Just out of curiosity, between 0 and 1. I'm trying 1/2. Guys, if I put 1/2 in, 1/2 cubed, definitely going to be a positive. Up here, 1/2 subtract 1, that's going to be a negative. 1/2 plus 1 will be a positive. Denominator, 1/2 plus 4 is going to be a positive. I did that quickly. Look at it right now and make sure my signs are good. Yeah, my signs are good. Guys, what is that all together? It's a negative. Now you gotta use it. No, it says you're looking for something greater than 0. So now there's one where I do not shade. Okay, and then of course you have to test the other intervals. I'm not going to finish it up completely here. But I saw something like this being done on the quiz. This one's a little bit more lengthy than the one on the quiz. Are you guys with me? Critical numbers and tests, critical numbers and tests, critical numbers and tests, called sign analysis. So I thought I would point that out before I jump into everything I need to do here. And what else do I need? Something else, yes, something else I noticed, and I should point out, is this, part B. Looks like this. Solve. And this one, guys, looks like, let's try to find where I am. Here I am. 3 over x plus 5 is less than, there we go, 2 over x minus 4. Tell me, what do we do there? It's another inequality. What are you going to do? Go for it.
X can't be negative.
Leo, right? Yeah, Leo, what are you going to do first?
X can't be -5, X can't be positive.
Right off the bat, x cannot be a -5, x cannot be 4. I agree. I agree. Something else has got to be done. Where's the 0? You gotta have one side to be 0 on these. My first one had the 0 there in it to begin with. So I don't have a 0 here to work with. So what should I do? I can move this term over. Here we go. And absolutely, when I move it over, guys, it's gonna be 3 over x plus 5. When I move it over, subtract 2 over x subtract 4 less than 0. Now I got my 0 in there, just like this one had, a 0. Then, the difficulty is, can anyone tell me now before I go any further and actually use sign analysis, now what should I do? I have two fractions on the left-hand side. And usually if you have fractions, you probably are looking for what? A common denominator. So I like to put those two together. What would serve as a nice common denominator for those two? And in fact, I'll help you out here. X plus 5, x subtract 4 will be my common denominator if I want to put them together. If that's going to be my common denominator, if I look back at my fractions, the first one's missing the x subtract 4, so I need to put that in there. And of course on top also, this is a lengthy problem, x subtract 4 is missing x plus 5, I need to put it in. And then figure out what this is on top. Now guys, I see 3x subtract 12, we'll bring it over here. And looks like maybe I see a negative sign was here. So it's a negative 2x minus 10. If I use the distributive property. It's right here. So if you guys agree. Combine like terms. If I combine like terms, at this point, in the red, I'm going to end up with 1x subtract 22. On the top there, combining like terms. The bottom part is my common denominator, just leave that. Again, this one came from a calc textbook. Now we're down to there. Now you gotta solve it. Now tell me, what are the critical numbers now, since I've simplified somewhat? What are my critical numbers if I were to go to a number line and start this sign analysis? What's my critical numbers?
Negative 5 and 4.
Okay, here we go.
Negative 5 and 4.
Negative 5 and 4 was mentioned earlier. Negative 5 and 4 cannot, let's be open to show, cannot be used for short. Now I've got another number in the red that I should consider as a critical number. What is it?
22.
22. Set the top part equal to 0 and get 22. But 22 is way out here. And my number line is out here at 22. Now what should I do? Because back on this one, I darkened in some of my critical numbers. What am I allowed to do here? Should I darken that one in? Why?
No equals.
Thank you. There's no equals to save me here on this one. It just says less than 0. So this one is also open. Now I'm not going to go through the complete solution. We'll just set this up for you. So guys, those are my critical numbers. This was a little challenge of a problem. And then, without me going through it, you know what to do next. You got to test here, here, there, here, at your choice, whatever number that is, and patiently put them in here and see if you get a negative result. Less than 0. If you do, you get to shade in. Let me test at least one interval. Guys, I'm going to just at random. Let's make sure all my numbers are in there correctly there. I'm going to test between here. Give me a test number.
Negative 3.
Negative 3. We'll test negative 3. Lots of numbers in between there. If I test negative 3 right back here, negative 3 subtract 22 is a negative 25. That is a negative. Negative 3 plus 5 is a positive 2. No problem. A negative 3 subtract 4 is a negative 7. No problem. I think I did all that correctly. Watch my signs there. Guys, all together, what is that? Is that a negative over a negative? Or is it going to give me a positive? Now looking back, is that what I was looking for? No, so I can't shade. Then of course you have to finish it up and find what may work and test the other intervals. A little recap on what I observed last time when I scored the quizzes. Sign analysis, sign analysis, sign analysis. Powerful method, but you gotta be careful with it. Okay, so that should be finished up. Now letter C, and then I think I'll move on after this. Let me see what I have here to point out. I always make notes when I score papers. This one. This was not a your quiz, but a student's asking. Given this function, all I want is find its domain. What am I allowed to replace x by? I see hands going up already. What am I allowed to replace x by? And by the way, do not think square root x squared plus 9 is x plus 3. It's not. Okay, someone tell me right quickly why square root x squared plus 9 looks like it's screaming at you. Can't you just go ahead and call that x plus 3, Professor? Why can I not?
It's being square rooted.
Okay.
It's being square rooted, so that would be 2.
No, something else. Why can I quickly say, and I know what I'm gonna do this, guys, on the side. This is not equal to this, which looks so tempting to say, wait, Professor, it is. No, it's not.
X plus 3 squared is not equal to
Yeah,
X.
if I square it, check a square root, you square it. If I square this, if we think that's the answer, and you do this, you're gonna end up with this. Not that. So you can't do it. So I gotta leave it. I just thought about that. Will not work. Now though, let's get back to the domain. What am I allowed to replace x by? Are there any restrictions?
3.
You have lots of these on the exam on Monday.
Anything greater than or equal to 0?
Okay, tell me x squared plus 9. Underneath there must be this for a square root always. The part underneath the square root to make the square root have meaning to it, it's gonna be positive. You can't take the square root of a negative number. Now, is there anything wrong with x squared plus 9 is greater than or equal to 0? What can x be to satisfy that statement? May I replace x by any number I wish? Give me one number you can replace x by. Tell me, I saw a head shaking no. Give me a number.
It doesn't exist.
Like what?
There's no number.
Yeah, it's always true. You can stand here all day and replace x by -4. If you square -4, it's 16. 16 plus 9 is 25. 25 is greater than 0. Replace x by any number you wish here. And you'll satisfy that statement. Therefore, my domain is open. And I like to express mine like this. Or all real numbers will work. Everything works here on this one. Now though, a student was asking, Professor, before I leave all this, suppose the function looked like this. And it was g of x is equal to, this one's a little bit more demanding. It was a square root x plus 3. I don't know whether we did this one in class or not. It's this. X squared subtract 9x plus 20. I want the domain. Now there are some restrictions on this one. Okay, let's go to the square root part first. What do I know about square root? Since I see a square root, it makes no sense unless you identify, show me that this underneath here must be this. You can't do a square root on a negative. And that implies x is greater than or equal to -3 when you solve for x. So that's part of my answer. At the same time, I'm staring at that denominator. What can I do in my denominator? I think of factors. Into x subtract 5, x subtract 4. Which now tells me I'll put a comma there. Down there, what can you tell me about x is down there? Can I let x be anything at all? I cannot let x be what numbers?
5 and 4.
5 and 4, right, like that, 4 and 5, because you end up with a 0 denominator, which you can't have. Guys, that in essence is my domain. So right now, on the side here, we have that x must be this, for the top part, numerator. At the same time, x cannot be these two numbers. So when you break it down, that's my domain. Now you get outside that, this thing will not work. Now I'd like to put this in interval notation for a final answer. Guys, this says, visually, This says on a number line, you are saying everything to the right of -3, including -3, is supposed to work. I agree. I'll just shade in and show that. That's what that means. But at the same time, I cannot use what numbers?
4 and 5.
So I gotta show by the time you reach 4, you better slow down, because I cannot use 4. Open. 5. Open. Now, can someone in this clever class tell me, what would you now say in interval notation is my domain? Does anyone have a guess? That's it. Leo,
Bracket -3, (4).
hang on, bracket -3 up to 4. Should 4 be open?
Oh, yes.
Okay, then union,
Union 4, (5).
look at that.
Both open.
Then union,
5, infinity.
perfect. There's the answer. That's my domain. Now that's what I wanted to recap. Before I jump back into difference quotient and stuff like that. Are we okay, guys? Yeah.
I'm having a hard time understanding when to completely get rid of variables in the denominator and when to just be able to get them there and solve that way.
Okay, hang on just a second. You read, for example, like this last one here?
Maybe if we're looking at B, for example,
Oh, up here?
no, down, where it says x minus 22 over,
Oh, got you. Where was that? Down here,
yeah,
somewhere. Okay, you're concerned about, tip me again.
I'm not understanding when to leave variables in the denominator or when to just leave the denominator and when to multiply it out and just,
Ah, beautiful. I got you. You're saying, Professor, should I just leave it? I think originally, where was I down here? Are you telling me that maybe I do realize this, when you expand it out, would be this? For my denominator.
I'm sorry?
Okay, now if you see that, and then I'm looking for restrictions, please factor this if you can, which we'll factor into this. So if you see it like this, and I'm looking for restrictions or for a domain, you better factor so you can see the numbers that cannot be used.
But I guess, when do we know when to go further and just completely get rid of the denominator?
Oh, I got you. To completely get rid of these.
Yeah.
Got you. Here we go, I think. If you have a square root on the bottom, I think maybe, if you have a square root in that denominator, here we go. Then you know, and I know, and I'm gonna make it look like that guy. There, something has to be done. We do not in math want a square root in that denominator. We have to call it rationalizing. Turn an irrational number into a rational number. Does anyone, just out of curiosity, I think maybe what you're thinking?
Yeah, no, I'll think about how to word it.
Okay. But just in case, guys, can anyone tell me how to get rid of that square root? Because you're not supposed to leave a square root in the denominator. Does anyone have an idea what you have to do to this one that I just created right quickly to get rid of it? Go for it.
Multiply it by square root plus 1.
Plus 1. He says multiply numerator and denominator by radical x plus 1. He's got something in mind here. Now, I'm not too concerned about the top right now. I'm really concerned about that bottom part. Now, if I multiply the bottom part denominator out, right here, by FOIL, or just expand it out, guys, I think you end up with, look at this, that now becomes merely x minus 1 down there. No radicals. The radical's gone. If I multiply by what he suggested I multiply by. Okay, so that may happen. Yeah, when you think about that, let me know. I'll jump into it. Guys, that's my recap. I took a little time there, but I thought, no, I gotta do this after I scored the quizzes and I saw types of mistakes being made here and there. Just get ready for that exam. You guys who came a little late, the exam is Monday. Mr. Park. Anna, please, both of you, send out a message to the students and remind them the exam is gonna be Monday rather than tomorrow. We need a little bit more time to get ready for this exam. Okay, guys, all that's done. Now, here we go, part 2. I'm back in where I should be now, part 2. I want to do this. Yeah, here we go. Functions. And we know the notation f of x, g of x, h of x. We know the notation here. Now what I've done here was, the notation is that, number 1, guys, please help me out. Mention something that is associated with dealing with functions. What could I ask you on the exam on Monday if I say f of x equals, I'll give the function to you. What could I ask you to do?
Find the intercepts.
Do it again.
Find the intercept.
I could. Do something else.
Find the domain.
There you go. Critical in math. They want to know what that domain is. I'm gonna try a few examples here shortly. Also, if I ask for the domain, they may also ask for the range, the y's, or a function. Number 3, I pointed out, and you guys may also recall other things here. Yeah, the difference quotient comes in under here. So I'll recap. And a student just asked me, said, Monday, Professor, will you place that quotient, difference quotient formula for me? I more than likely will. Really says this. I know it looks strange. You guys don't even know what the h represents down to a calculus. But right now it's just f of x plus h, subtract f of x over h. It's called the difference quotient. We did just a few yesterday. Domain, range, difference quotient. Anyone recall anything else that maybe is associated with dealing with, working with functions?
Transformation.
I'm not going into transformations today. That will be done today, yes. Do it again.
Maximum minimums.
The max min, beautiful. Got a handout coming up today about that. Max min, graphing the function. We're gonna just put sketching. Those things can be done. Now, with all that said, I may be leaving a few things out here. Part 3, let's see, what did I do here to keep everything organized for us? Oh, I did. Given, I gave you a function. I named it for you. F of x is equal to, this one is this. Two x squared plus 3x subtract 5 over x plus 5. And the first thing I would like to find is, with your help, can you tell me its domain? Functions have a domain. And thank goodness there's no square root on this one to worry about. So can anyone look at this and tell me, and maybe what you might want to do as a student to see what it might be? Any ideas? What is my domain? What am I allowed to replace x by or not replace x by? X cannot be for sure -5. That will make a 0 denominator, and I'm good. By the way, I do see, I think the top, the numerator, I think it will factor. I'm going to go ahead and put it in factored form, just for a reason. Up here, 2x, x, now I think it's going to be a +5 here, a -1 here. Let me step back and look at it. Looks good. It does factor. Now, should I include, maybe since I've been in factor form, should I include something from that also in my domain? Or is my domain good? Is there a square root up there involved? No. So my domain is what you see right now. That's the only thing I need to worry about. Don't let x be a -5. Can someone tell me right quickly, what does that look like if you express it in interval notation? You're saying x cannot be a -5.
Open negative infinity.
Okay,
comma
here we
negative
go.
5.
Open, negative infinity up to
Negative 5.
open and
Open,
union.
Union, open, negative 5 to infinity.
Perfect. Said the same thing. There's my domain. Now, I heard a student tell me earlier, I will not graph this. I'll put right here, maybe sketch a graph later on. I'm not going to sketch the graph of this one. Can anyone tell me, without actually sketching it, where would the x-intercepts be located on the graph if I did graph it of that function?
1 and negative 5 over 2.
Let me do it again.
Is it 1 and negative 5 over 2?
Okay, how'd you get that?
From the numerator.
Okay, now, so how do you find an x-intercept, guys? When to find an x-intercept for any function, what must one do to the function itself to find x-intercept?
That's the whole function.
You're going to set the function equal to 0. F of x equal to 0. So let's put right here, set y, or f of x, equal to 0. If I do that, mine looks like this. And I am going to use that factored form on top there. I think Jonathan's already given the answer to me. But this is the process always. You set the function equal to 0 if they ask you to find the x-intercepts. Now, if you try to solve that, I like cross multiplication when you can cross multiply. It's up to you. I like to do this. Just multiply these two together. Multiply these two together. That's a quick way to do it. I see 0 times x plus 5 gets me nowhere. That's 0. And in the other direction, you really get this. And there's other ways to solve that. Split this up, and Jonathan, I think you already told me what, negative 5 halves?
Negative 5 halves is 1.
And 1, and you are correct. Those are my x-intercepts. Those would be on the x-axis if I were to graph this. Yes?
Why did you set it equal to 0 over 1?
Yeah, but what happens if you're on the x-axis? Here we go. If you're on the x-axis right here, hang on. Let's say the graph looks like this. And its x-intercept that I'm looking at right now is right there. And I say it's 1. Label it for me. Write it as an ordered pair. It is 1, but as an ordered pair, could I write it as 1, 0? Is every point on the x-axis could be listed with a 0? Are we actually at 0 on the x-axis? Okay, did I answer that question for you?
Yeah.
Yeah, so that's why you're going to set y equals 0. Always, or f of x equals 0. If they ask you to find an x-intercept. Guys, all these points, not just mine, all these points, if you label them, as a y, it'd be a 0.
I understand why you set it equal to 0. I'm asking about 0 over 1.
Oh, this right here, I just did a cross multiplication. You wouldn't have to do that. You could do it like this, not put this. I've had some students do this, say, Professor, can I just multiply both sides by x plus 5? That's another way to do it. Just multiply both sides by x plus 5. And solve the equation. Okay. Yes?
So you just want to get rid of the denominator?
What's that now?
So you just want to get rid of the denominator?
Beautiful. Now, she says, Professor, could I have just gotten rid of that denominator? To find the answer quickly, Professor, could I just quickly have taken that on the side, set it equal to 0, but you said set it equal to 0, and get the answer without all this other business going on? In this case, yes. Just set that numerator equal to 0, and then you're on your way. Sometimes you can't, but in this case you could. So guys, got my x-intercept. Now, without graphing, I'm definitely not going to graph this one. Anyone tell me where is, if there is one, where's the y-intercept?
And f of 0.
Now, if you go through, replace f by 0, a little bit different. You don't set something equal to 0, you find f of 0. So if I go back and replace all those x's by 0, no problem. You end up with this. And over here, 0 plus 5. I'm stepping back and looking at, guys, when I do this, help me out. I think it's a negative 5 over 5, is it?
Yeah.
So we end up with a negative 1. We'll put a comma here. I prefer to write that answer like that. That looks better. It's 0, -1. This over here was like, written like this for an x-intercept. Looks much better like that. There's your y-intercept. No graph. Yes? No? Okay. So all this is about function. Now we're gonna finally eventually sketch functions, definitely. But I have not asked you to sketch yet. Just out of curiosity. I threw a difficult one at you. I give it to this as your function. Does anyone think they know what that strange function, 2x squared plus 3x minus 5 over x plus 5, what that thing would look like sketched? And it must pass the vertical line test after you crack it. Does anyone think they know the shape of it? Is it a parabola? I don't think so. Straight line? I don't think so. Does anyone think they know what the shape looks like? If you do, you're doing well. But they don't show you this until chapter 4. This is what the graph looks like. We're not going to sketch the graph until chapter 4. Okay? Now Anna and Park probably knows what this thing would graph into. We're going to just hold off until chapter 4.
Would it be a hyperbola?
You keep on missing that word hyperbola. You love that word hyperbola.
Or would it be a function with asymptotes at?
There you go. I heard the word asymptote. Some of my students may not even know what that is. That'll be chapter 4. There will be an asymptote involved, yes. We don't have to worry about that right now. Okay. Guys, that's another thing I had to point out. Part 4. Yeah, I think I have a little practice for you guys to do for me. Okay, part 4. Yeah, I do. Given this. F of x equal to x cubed subtract 4x. It's a function. Now, my directions on this one is, like you might see on the exam Monday. Yes, sketch this one. I want you to sketch of this one. Okay. Now, I think I sort of did something like this yesterday. Okay, let's find the x-intercept, y-intercept on this one. X-intercept. Routine always is to set the function equal to 0. If I do that here, you got this. Always sets a function equal to 0. Now, can anyone tell me what would you do here in an attempt to solve this? Because it looks like there might be 3 x-intercepts. Can anyone tell me what would you do to find them? On x cubed subtract 4x. You want to factor how? I want to factor.
Take out x.
Take out a
X.
x first, common factor. That will take me down to that. Now what?
Try to factor it further.
They'll factor further. The difference is squares. Okay, guys, when I look at this now, this is looking cute. Split this up, all the factoring's done. Set each one of these equal to 0, which we know to do. I'm just going to tell you what the answers are. You'll get 0, 2, and -2. And since I'm talking about x-intercepts, I'm going to do this. I prefer it written as an ordered pair. This is an ordered pair. Ordered pair. That's my x-intercept. I don't have the graph yet, but I know the x-intercept. In fact, I have 3 x-intercepts. Now the y-intercept. Always. Process is to find f of 0. You go back and replace all the x's by 0. I don't think this one's very exciting because when you find f of 0 up here, you get 0 cubed. Subtract 4 times 0, you end up with 0. So we'll write minus an ordered pair like that. So I have the x-intercept, y-intercept. I don't have the graph yet. At least I have those to work with. Guys, to sketch it, here we go. On the side, here's for a rough sketch. Let's do this. I have x-intercept at 0, 0, I'll mark it here. 2, 0, let me go out to 2. Mark that. -2, and I'll mark that. Those are my x-intercepts. Y-intercept, 0, 0, I've already marked it. Now, can someone tell me what did we do yesterday that we've done so many times in class that might help me to get the shape of this graph? Because the graph's got to pass through those x-intercepts. Anyone recall what we did? We did sign analysis. We did the sign analysis. We did this. We did this. Get back here. It's maybe the same problem we did yesterday. Here and out here. Guys, out to the left of -2, it's up to you. I'm gonna try -4. In between, I'm gonna try -1. In between 0 and -2. Out here, I'm gonna try 1. And out here, I'm gonna try +4. Let's see what sign comes out. Okay, with -4, where am I gonna take it? I'm gonna take it back into the factored version, which I think is better. And that was this. That's my factored version of that. Now let's put in, I'm testing -4. Guys, replacing all those x's by -4, definitely have to see a negative here out front. -4 subtract 2, -6. -4 plus 2, -2. All those negatives will give me a what? Negative. Now I'm testing -1. Let's go back. Replace x by -1. Well, it's negative, of course. -1 subtract 2, -3. -1 plus 2, a +1. All that I think is, I think it's positive, isn't it? Is it positive?
Oh, yeah, sorry.
A negative and a negative is positive. Next one, I'm testing, where am I? Like it's between a 1, testing 1 over here. Guys, testing 1, going back, I see a positive. Use that in, a negative, a positive. If I made no mistake, replacing my 1 here, which altogether is a negative. Out to the right, my last test is 4, replacing all these x's by 4 to save me a little time. I think they're all positive, which gives me a positive. Woo! Now what's that tell me? What did that tell me yesterday? I don't have the graph yet. What did that tell me? Yes.
Tells you where it's falling and where it's right.
Yeah, even better than that. I understood what you said. But what does it really tell me? I know right here you said, Professor, I know sign analysis. It came up to be here negative. Well, you saw me also using sign analysis on an inequality. And I had to shade in, right? This is not an inequality, this is a graph itself. So what do you think that negative sign tells me on this graph? Where should the graph be located? Under. Negative means under, below in graphing. So I don't know exactly what the graph looks like, but I do know it should be below in this interval. Now, my guess is, without plotting points, it probably has a little curve to it. It stays below and then goes up and picks up -2. It's got to pick up -2, that's the next intercept. Then between these, I tested between -2 and 0, I tested -1. We got, all together, we got a positive. What should be happening in this interval? It should be above. How far above does it go? I don't know, you don't know, but it's got to look something like that. It's going to be above the x-axis. Next, I think we ended up with a negative which tells me in this interval it's gonna drop down. How far down does it drop? I have no idea, but it's gotta come back up and pick up that x-intercept. Then finally out to the right, we tested and got a positive. What's that tell me happening out here? It's increased or staying above the x-axis. And there's a rough sketch of the graph. Who would think that you can graph this in no time by using sign analysis? This right here. X cubed subtract 4x, that's its picture. That's its graph. Based on sign analysis. Above, below, x-intercept, y-intercept. Guys, how's that look? Now, I want to answer this. One of my students is really concerned about this. Jonathan. Jonathan says, Professor, suppose you ask me to do this, and I don't think, let me check, guys, let's see if I made my lessons connect here, like I usually try to do here. Maybe not. Okay, on the side here. Suppose, Professor, you saw this. Beautiful. And on the exam Monday, you see, solve this inequality. You say, I'm like this, Professor, no problem. I'll factor this. No problem. Factor. Difference of squares. Is that true? Then go to sign analysis, go to a number line, place those critical numbers, and start testing. That's what we've been doing all along. Is that true? Look at this. Is this the same function? Sometimes it happens. Is this the same function that I just drew the complete graph for? So someone tell me, since I have the complete graph, let's not go through sign analysis again. I've got the complete graph now. What would you look at on that graph, do you think, answer this question without drawing a number line and going through sign analysis again, even though it would work? But I had the complete graph. What would you look for on this graph to answer that question? Describe to me just in terms, what does that mean? Go for it.
It's just when the graph is over, like f of x is over 0.
Above 0. Above the x-axis. Now it's above the x-axis, and Jonathan, here goes. It's above the x-axis here. I'm actually shading that little piece there. And it's above the x-axis here. Are those the two spots where it's above the x-axis? That's the answer. Now, I don't have the time. You don't have the time right now. If you went through this by using sign analysis like I was using over there, you'll get the same answer. Well, I do it much quicker now since you have the complete graph in front of you. The answer for this one, without going through sign analysis, based on that graph is, tell me when is this happening? Between -2 and what? 0 and, or union what else? 2 through infinity. Without touching sign analysis, just look at the graph. Let me write that down so we got it here. -2 to 0. And union, I think we said 2 through infinity. And there's the answer. Done. Now, would it be nice Monday? I'm creating my test already. Constructing my test. Would it be nice for me to place a graph there and say, solve? And I'll say, solve this. And you say, Professor, I know how to solve this by sign analysis. I'll let you do it. But wouldn't it be nice if I say, let's graph it first and have the graph on the side? You could get the answer a little bit faster just by looking at the graph. You've solved the inequality without going through sign analysis. Guys have done a lot of work here already. So far, so good? Making sense? Okay. Domain, range, hang on just 1 second here. On this one, I got a nice little handout for you here shortly. On this one I just did. Here we go. Oh, God, we can't answer everything I need here, though. On this one, geez. Is there a point somewhere in here, do you think, that will act like a maximum? It'll reach a high point and it's going to come back down. Do you think there'll be a maximum in there somewhere? Right in here somewhere. Do you think right here might be a minimum point somewhere? I don't know exactly where on that graph for that function. So it looks like there's gonna be a max and a min, and you will not be able to find them until calculus. That's why I love calculus. Calculus will show you exactly where they are. Right now, I just know they're there. You have to use calculus to find exactly where they are. Okay, guys, so I got max, min. Okay, with that all said, that's gonna lead me right into where I should be. Let's see if I have all my handouts here correct. Oh, yes. And you guys returning these handouts are helping. Okay, now a little story about my handouts. I do so many handouts. The college here does handouts or will make copies for us as professors, but you gotta put it in maybe a week ahead. Sometimes the night before is when I finally decide, no, I want this worksheet. So I can't always ask the college to do it for me because I can't plan maybe sometimes that much. So I stop by my local FedEx, and they know me there. And a little short story. I walk in to make my copies, and those guys who are working there, they're just college kids mostly working there. They finally got to know me, and they were a little nosy, and they saw what type of copies I was making. They said, "Oh, you're a college math professor?" I said, "Yeah." I said, "All right, are you taking math?" And one of them said, "Oh yeah, I'm taking a math course at another college." I said, "Really? Oh yeah." I said, "How's it going for you?" "Not too well." I said, "Oh, okay." But he kept watching me make copies. And then pretty soon I went in, the next time I stopped by, there he was again, waved at me. But he had a book with him. So he came over and, "Hi, Professor, good morning." I said, "Hello." So he had a book with him. He had his math book. He says, "Professor, could you help me out with some problems here?" I said, "I'm here to make copies." "What's wrong?" "I'm not a tutor." "Professor, could you, of course, as a professor teaching, you do." I said, "Okay, let me take a quick look as copies are being made." And then I looked at it, and you know how students are, you probably the same way. Not only after I showed him how to work this one, he smiled and said, "Oh yeah." Oh no, he flips through the pages and he finds something else. I was being there all day helping this kid. So I took a little chunk of my time, and so I had about $75 worth of copies I had to pay for. I stacked up my papers, and I looked at him and I said, "You're gonna pay for this." And I knew those guys there, and I just walked out. Walked out. So that he had to pay for it. Absolutely. He didn't pay for these right here, but he paid the pass. So guys, I'm gonna do this. First, we're gonna take a look at one side where the graph is given to you. And then they ask you questions about max, min, increasing, decreasing. And I hope I marked this one well enough we can actually see what they are here on this one. So we'll identify this. And then the other side, when I get to it, are some, what I call parent functions, elementary functions. What they look like graphed. Okay, so we need to take a look at this. Anna,